Another example of integration by parts where defining u and dv is a little bit sneaky. This time we have a definite integral, 0 to 1/2 arc cos x dx. Let's start by letting u be equal to the function arc cos of x. Seems like a pretty easy way to start it. And then let's let dv be equal to dx. Okay, so that's going to be arc cos x, and then dv is going to be our dx. We might not have taken the derivative of arc cos for a while. And so that's where we might want to have a list of derivatives to remember that it's actually the opposite of the derivative of the inverse sine, which is going to be opposite 1 over the square root of 1 minus x squared dx. And then, much easier, antiderivative of dx, think of it as 1 dx, antiderivative of 1 with respect to x is going to be x. Using our formula, uv, v du, what we're going to do is we're going to say that the integral is going to be equal to x arc cos x, definite integral, 0 to 1/2, minus the integral of v du, which is going to be minus a minus. I'm going to put the x in the numerator, square root 1 minus x squared dx from 0 to 1/2. So far so good, not too bad. Notice that clearly this is just going to turn into a positive because we have an opposite of a negative. So I'll just make that to a positive. Now, we've seen examples before where we have to use integration by parts again. This is not the case. We have the second integral. And before we go through and actually evaluate, we have to evaluate with the 0 1/2, we have to solve the integral that's left over. This one is a U-substitution. All right, so we have to be cognizant that integration has a multitude of different ways to be able to evaluate, and we have to make sure that we try all of those. So we don't want to use parts on this one. We're going to let u be equal to 1 minus x squared. Now be careful with the derivative of this. I've often seen students say, well, the derivative is going to be 2x dx. But it's negative 2x, okay? That sign has to drop down. So don't forget about that negative if you start out with a constant in front of your variable, all right? Now, we don't like negative 2. We'd really like to just have x dx. And so what we're going to do is divide by negative 2, and we get opposite of du over 2 is equal to x dx. And now we can substitute, right? So x dx is going to be our negative du over 2. 1 minus x squared becomes u. We're going to use our dummy variables. Okay, so x, excuse me, x arc cos of x stays the same. Okay, that's already evaluated. We're done with that. And then we're going to have plus the integral from a to b. X dx becomes minus du over 2. And then instead of square root of 1 minus x squared, it becomes square root of u. Some good news. We can factor out the negative 1/2, and we can rewrite the square root of u as u to the minus 1/2, all right, or the square root of u in the denominator. All right, so we're getting pretty close to being able to finish this one. So x arc cos of x from 0 to 1/2 minus, factoring out a 1/2, a to b, u to the minus 1/2 du. All right, so now we're going to go ahead and we're going to integrate that. So this is going to become x arc cos of x, still from 0 to 1/2. And of course, at the end, we have to contend with that, minus 1/2 u to the 1/2 over 1/2 from a to b. Now we can finally back substitute in terms of the original integral. The halves are going to cancel out, right? And if we substitute everything back, this is going to turn into x arc cos of x minus the square root of 1 minus x squared from 0 to 1/2. All right, so now's where it starts to get a little bit trickier because now we have to remember those inverse trigonometric functions, okay, when we evaluate. So we're going to substitute a half and we're going to substitute 0. Okay, we're going to be careful as we do this. So this is going to be 1/2 arc cos of 1/2. Okay, and that's going to be a little bit of a challenge to evaluate if we're not good with our inverse trig values, but we'll try to remember how to do that. Okay. That should say arc cos minus the square root of 1 minus 1/2 square. Okay, don't get too hung up on that. We'll get to it. And then we're going to substitute 0 in. So minus 0 arc cos of 0 and minus, this is still in this parenthesis right here, minus the square root of 1 minus 0 squared. Okay, now I'm going to erase so I get a little bit of room here. All right. Now, the good news is with this, there are some things that are going to simplify really nicely. In fact, 3 out of 4 of these expressions are going to simplify to the point where we don't have to do too much work. One of them is the inverse trig, which we are going to have to worry about. Okay, so one moment, I'm erasing. And I'm going to erase just a little bit more just to make sure we have ample room. All right, so 1/2 arc cos of x. I'm going to leave that as is. 1/2 arc cos of x, and I'm going to figure that out at the end. So 1/2 arc cos of 1/2. This becomes 1 minus 1/4, which becomes 3/4. So that becomes minus the square root of 3/4. Okay, that's not too bad. 0 times arc cos of 0. Now, arc cos of 0 is a number, okay, but we don't care. Okay, it's actually pi halves, but we don't care because we have 0 times that number. Then we have minus a -1, which is going to turn into a +1. Okay, so this is going to turn into +1. Right. Last thing we have to do, we have to evaluate this arc cos of 1/2. And just in case you've forgotten, this means that the cos of what angle is equal to 1/2. It's actually going to be pi-thirds. Okay, so this is actually going to turn into 1/2 times pi-thirds. All right, and again, a unit circle would be nice to be able to make sure you understand that. Minus, I know the square root of 4 is 2, so I'm going to have the square root of 3 over 2 plus 1. And one possible answer for this without a common denominator would be pi over 6 minus root 3 over 2 plus 1. If I was to get a common denominator and write everything with a denominator of 6, if I wanted to, it wouldn't be too bad, okay? And then I can also factor out a 1/6 if I really wanted to at the end. So I'm just going to show you a few different ways to write the answer. So another way to write this by getting a common denominator would be pi minus 3 roots of 3 plus 6 over 6. And if I were to factor out the 6 or the 1/6, I could get 1/6 pi minus 3 roots of 3 plus 6. All right. So a little bit of a challenge every time that we have these sorts of limits of integration. We have to not only evaluate the integral, but then we have to plug in and we have to be really meticulous about our computations. All right, 2 more examples, all right, and we're going to look at those in the next videos. And these are going to be types of integrals where we're actually going to have to solve in terms of the integral to be able to evaluate